All right, lesson 29 is solving radical equations, and our objective is I can develop skills in solving radical equations by using the rules for square roots, and it's really important in this particular lesson to check your solutions to determine extraneous solutions. So in our last lesson, if we found out that the square root of x or x minus 5 or whatever, if it was less than 0, if it was a negative number, there was no solution. This time, it's not going to be as obvious. Okay, so example 1. To solve the equation 6 equals x plus the square root of x. So a big hint for all of these problems is you want to get this by itself as much as possible. Okay, so anytime you have a square root, you want to get that by itself. So to do that, I'm going to subtract x from both sides, and I get 6 minus x equals the square root of x. Now to get rid of that square root, I'm going to square both sides. Now to do 6 minus x squared, it is not 36 minus x squared. Okay, it is 6 minus x times 6 minus x. So let's do the square. We're going to get what's called a perfect square trinomial. 6 times 6 is 36, minus 6x, and this is another negative 6x plus x squared. I'm going to write this in standard form. X squared, negative 6x, and another negative 6x is negative 12x plus 36 equals x, because the square and the square root knock each other out. I'm going to set everything equal to 0, so I get x squared minus 13x plus 36 equals 0. So now I'm looking for two numbers that multiply to make 36 and add up to negative 13. So if I think of the factors of 36, I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. It's going to be 4 and 9. And since they have to add up to negative 13 but multiply to be a positive number, they both have to be negative. Oop, that should be a 4. So I get x minus 4 times x minus 9 equals 0. So x equals 4 or x equals 9. But remember, the second part of our objective is we have to check, because it's not really obvious if it's an extraneous solution or not. So I'm going to plug these back into our original equation. So first I'm going to try 4. 6 equals 4 plus the square root of 4. 6 equals 4 plus 2. Yep, that works. Let's try 9. 6 equals 9 plus the square root of 9. 6 equals 9 plus 3. 6 equals 12? No. So x equals 4 is a solution. X equals 9 is extraneous. Okay. All right, so let's look at this one. Remember, up here, I said to try to get the square root by itself as much as possible. So what I'm going to do is I'm going to subtract 1 from each side. 3x minus 1 equals 2 square root of x. And now what I'm going to do is I'm going to square both sides. And again, use the table. If you're not comfortable with the perfect square trinomial pattern, just use a table. The table will never fail you. 3x times 3x is 9x squared. Negative 3x, negative 3x plus 1. So I get 9x squared minus 6x, because I have two of those, plus 1 equals, all right, 2 squared is 4, square root of x squared is x. Now I'm going to set everything to 0. So I'm going to subtract 4x from both sides. I get 9x squared minus 10x plus 1 equals 0. And I'm looking for two numbers. If I multiply 9 times 1, they're going to multiply to make 9 and add up to negative 10. It's going to be negative 9 and negative 1. I'm going to use that, I call it the Ramsel method, 9x minus 9 and 9x minus 1. You just bring this coefficient over to both, and then you see, okay, do these have a common factor? Yep, I can divide by 9. So this becomes x minus 1. This one stays as 9x minus 1. Okay, so let's look at our options for x. I'm going to write it up here. Sorry about that. Okay, so x equals positive 1 or x equals 1/9. Remember, the second part of our objective is we have to check our answers. So let's plug these into our original equation. Our original equation was 3x equals 1 plus 2 times the square root of x. So let's first try 1. 3 times 1 equals 1 plus 2 times the square root of 1. So 3 equals 1, and the square root of 1 is just 1, so 2 times 1 is 2. 3 equals 3. So that one works. Let's look at 1/9. 3 times 1/9 equals 1 whole plus 2 times the square root of 1/9. So that becomes 3/9, which is less than 1, equals 1 whole plus, okay, some other number. Okay, so it's actually going to be the square root of 1/9 is 1/3, because 1/3 times 1/3 is 1/9, so it becomes 2/3. So let's think logically about this. This number is less than 1. It's a fraction. This number is greater than 1. There's no way they can be equal. So this is also extraneous. Okay. Let's look at number 2. I have 3 equals 4 times the square root of x minus x. Remember our trick? We're going to get anything with the square root by itself as much as possible. So to do that, I'm going to add x to both sides. And I get 3 plus x equals 4 times the square root of x. Now, to get rid of my radical, I square both sides. Again, I'm going to use my table. I get 9, 3x, x squared, and 3x. So I'm just going to write it out in standard form. X squared plus 6x plus 9 equals, and then 4 times 4 is 16. Square root of x times square root of x is x. Okay, let's bring that over. So we get everything all on one side of our quadratic equation. Okay, now I'm looking for two numbers that multiply to make 9 and add to -10. I just found that, sorry about that guys, I just found that answer in the previous problem. Okay, and so I know that this is -9 and -1. My coefficient is just x, it's 1. So I have x minus 9 times x minus 1 equals 0. So x equals 9 or x equals 1. Let's plug these back in to see if they work. Is 3 equal to 4 times the square root of x minus x? Let's try 9. 3 equals 4 times the square root of 9 minus 9. Yep, that worked. Okay. So 9 is good. X equals 1. 3 equals 4 times the square root of 1 minus 1. So anywhere I saw an x, I just plug in 1. So that's just 4 times 1. So both of those solutions are good. All right, let's move on. On to page 2. All right. So, right now, our radical is all by itself. Okay, so we're going to square both sides. This just becomes what's underneath the radical. This is a perfect square trinomial. You do the first term, x squared. Combine them, -1x, and then double it, plus 1. So now I'm going to set everything equal to 0. I'm going to bring the x over here, and I'm going to bring the 5 over here, subtract 5. So I get 0 equals x squared minus 3x minus 4. So I'm looking for two numbers that multiply to make -4, add up to -3. So that would be -4 and +1. Okay, x minus 4 and x plus 1 equals 0, x equals 4, or x equals -1. Don't forget to check your solutions. So, got my original equation. Okay, so I'm going to plug in 4. Square root of 9 equals 3, 3 equals 3. Awesome. Square root of -1 plus 5 equals -1 minus 1. You're going to get 4, square root of 4 equals -2. Okay, and that is not true. So 2 does not equal -2. So -1 is extraneous. Okie dokie. And I'm actually kind of struggling with, because I know that -2 times -2 can give you a +4, but I still think that that's an extraneous solution. I might plug that in and graph it and see what happens then. All right, I'll get back to you on that one. This next one, square root of 3x plus 7, I'm going to subtract the other, equals -2 square root x minus 8. Okay, so I could go through and solve this. Like, I can go through and I can square both sides. I'm going to do it super fast. 3x plus 7 equals 4 times, because -2 times -2 is 4, x minus 8. 3x plus 7 equals 4x minus 32. I'm going to add 32 to this side, add 32 to that side, subtract my 3x, and I get 39 equals x. And if I plug that in, 3 times 39 plus 7 plus 2 times the square root of 39 minus 8 equals 0. Okay, so this is going to become square root of 39 times 3 is 119 plus 7 is 124. This becomes 2 times the square root of 31. Okay, the only way this can be true is if these are the exact same number and one is positive and one is negative. In this 124, it can be broken down into square root of 4 times the square root of 31, which gives me a 2 times the square root of 31. So you can't double a number and get 0, so no solution. Now, I actually didn't have to do all this work. Oops. I could have seen right here when I moved the 2 times the square root of x minus 8 over to this side by subtracting, I had the square root of something equals a negative. And we found out that that is how you get no solution. So I could have stopped right there. Okay, let's knock out example 2 and then we'll be done with this video. So I'm going to subtract the square root of x from both sides. So I get square root of x plus 3 equals 3 minus the square root of x. I don't know if this number is going to be positive or negative. It's going to depend on what x is. So what I'm going to do, and this one requires a few steps. I'm going to square both sides of my equation. So I get x plus 3 equals, and if I did my table, I'm going to do the table for this one. 3 minus the square root of x, 3 minus the square root of x. 3 times 3 is 9, minus 3 square root of x, minus 3 square root of x. And this is going to be positive x. So I have 9 minus 6 square root of x plus x. Now, we're kind of at our starting point because we have a square root. And remember, our tip from the front is we want to get this thing all by itself. So what I'm going to do is I'm going to move the 9 over, and my x's will actually cancel out. So I get -6 equals -6 square root of x. I can divide both sides by -6. Okay, so I get 1 equals the square root of x. So x equals 1. I'm going to plug that in and see if it works. Is the square root of 1 plus the square root of 1 plus 3, I'm looking at my original equation here, equal to 3. The square root of 1 is 1. This is the square root of 4. That works. So that's a good solution. All right, we're going to stop for now.